Just give me a minute. Uh, can you see the slide, so?
Yes, we can see the slide and you are audible. So I
Okay.
can see it in show mode.
Okay, in slideshow mode, it's visible. Okay.
Slideshow mode.
Okay, right.
Thanks, Deepak.
Okay. Thank you, Professor Richi, for introducing me. So I will be starting with this tutorial 2, large language models and text classification, how we are going to use that. So firstly, introducing myself, I am Deepak Niyal, part of Advanced Data Science Machine Learning Research Group in School of Computer Science and Faculty of Science, QUT. I am a third year PhD student working with text classification or social media data specifically.
Deepak,
Yes, ma'am.
sorry to interrupt. You are still at slide 1. Did you move to slide 2? Because that we could not see.
Okay, no, I'm the first one still.
Okay. Do you want to take it to sec 2 and see whether we can see your slide
Okay,
2?
okay, fine. Can you see the second one now?
Yeah, we can see.
All right. Okay, so I'm a third year PhD student at QUT, and I'm working on text mining and social media data. So currently, I have done text classification method in a supervised and semi-supervised manner. I have done my master's and master's from IIT Roorkee in computer science from 2012 to 2014. And prior to that, I have done my Bachelor of Computer Science from College of Engineering Roorkee. So I have been teaching in Graphic University, Dehradun for 6 years. And after that, I joined PhD with Professor Richi, and it's my third year. Even prior to that, I was working as a software engineer in Gurgaon, where I worked for 2 years. And here during my PhD, I have done an internship in Married Mind, Brisbane. And these are my publications. So before beginning the real presentation, this is a disclaimer. These are slides which are associated, and these material have been prepared for the course, Generative AI and Use Cases. And I think we have seen this disclaimer before where Professor Ritchie and Dewey presented yesterday. And this is our ADMRG research group team. So some of them are past members and some are current one, which are down there. And on the right side, they all are current members of our group. Now I will begin with the session objectives. So as Professor Ritchie has discussed in her to our slides about Gen AI and language models. So I'm going to discuss a bit of those things. I will not go into detail of theoretical things because now, okay, I think is there any issue? Let me check. I have somebody's raising hand. Okay, slides are not changing. Yeah, all right. Okay, so these are the session objective where we are going to uh, learn about the basic knowledge of Gen AI and language models and describe how these Gen AI or these language models are used to implement AI application. Specifically, I am going to talk about BERT, Robota, and XLM Robota, ensemble of these three, how we are going to present these models as classification. And then we'll talk about uh, step-by-step walkthrough of workflow, how we are going to run the code, starting from pre-processing the data set and then model training, evaluation, and how to do ensembling and all these things. So I will show some of the data sets that I have used. I have already shared some the slides and the code. I hope you have access to that. So firstly, we'll go through the notebook, and then I will try to compile whole code, the notebook or Jupyter notebook code into .py file, which you can execute as a script. So we are going to do that. So as an introduction, firstly, we'll understand a little bit about LLM, not going into much detail of the theoretical part because Professor Ricci has already discussed that. Then key models, which is BERT, Robota, and XLM Robota. The framework that we are going to use here is PyTorch, and we'll do see some of data sets and code. We'll walk through them for the training and the testing. I hope slides are changing now. You can see them. So firstly, maybe we can start with one question. What does LLM stand for? Because we have been talking LLM so far. So first option is large learning model, second linear language model, third is large language model, and fourth is linguistic language model. So easy one. So everybody got the right answer for this one. All right. So everybody got correct answer for this one. So as we are going to discuss the text processing, so we can do classification and you can do image classification, you can do text classification and other classification as well. But right now we are going to stick towards text classification only, as we are working on the natural language processing. And there is a really good course on the Hugging Face. I have put a screenshot here. You can see that, and there is a link above, huggingface.co learn/learn/slash NLP course slash en/slash chapter 1. So if you are interested and if you are not aware of this course, you can really go into that later on when we are done with this presentation or this hands-on, or maybe in between you can go through that, read some of the stuff if you are stuck in any of the things, or if something confuses you. So this is a really good course where you learn about the workflow of handling data and seeing all the language models. So another question which you can answer: which of the following popular architecture is used to train large language models? So the first is decision tree, second is transformer, current neural network. It should be recurrent neural network, RNNs, and the fourth one, convolutional neural network. So answer two or answer B. So everybody got correct answer to this as well. So these are some of the basic questions. If you are a little bit familiar to large language models, you can answer them easily. Okay. Just a second. I'm not sure why. Let me skip from it. It's not changing the slide. Yeah, now it does. Okay, so now talking about BERT, because BERT is the first thing that we are going to discuss. So this paper was released in 2018, and it was the NAACL 2009 19 best paper. So this has changed the NLP in a drastic way. Earlier used to be things like we can only process without context. The things were without context, and when the BERT came, the things became contextual. We can do bi-directional understanding of the text. So contextual and bi-directional things change the NLP in a very good way. And after that, BERT has been used by many other large language models. So it's a fine-tuning based approach on a deep transformer encoder. And the key is about it learns representation based on bidirectional context. That's the important. So if you see here, it says both left and right context are important to understand the meaning of words. So there are two examples here on the screen. You see, We went to the river bank, and second example is I need to go to the bank to make a deposit. So if you see the word bank here and word bank in example 2, both have different context and different meanings. So if a model can understand the language very efficiently, it can really identify this bank in the example one is different from the bank in second example, and BERT is capable of doing that. So there has been two pre-training objective of this BERT model. One is masked language modeling plus next sentence prediction, which Professor Richie discussed in her slides. So I will mostly go into the implementation part, how we are going to implement. So the Hugging Face course that I have shown you, there is a Hugging Face transformer library, and it provides pre-trained BERT models and utilities. Right, you can use them, you can import them, and you can use any of the versions that are available in the BERT or any other models. We'll go into detail of other models as well, but you can get any different versions of these models and implement them for different downstream tasks. So firstly here you can see that we have different versions. Firstly, we have base or large models, and the models that you need to use, you just need to use BERT base uncaged or BERT large uncaged. So we generally use BERT base uncaged. It's a smaller version. If you want to use larger, it will take more resources and more computational power. So uh, when you are working with on a resource constrained devices, it's good to use the smaller ones. Then another one is caged or uncaged. So it is about preserving the case sensitivity of the text. So if it is a caged, it means if capital C is written or small c is written, it will be treated differently. But in case of uncaged, it's going to turn everything, or it is going to convert everything into small cases first. And then everything, whether it's capital or small, everything will be converted into smaller, and it will be treated similarly. Then there are distill BERT based uncaged models. So these are some smaller and faster versions. So if you have constraint of resources and you want to execute BERT models, you can use distill BERT based uncaged model. So instead of this BERT based uncaged, you can use distill BERT, and this is going to be is going to help you if you have more resource constrained devices. And then there is a mbert. Mbert is for multiple languages. If you want to work with multiple languages at once, then you can use mbert, right? And then there are some task specific variants as well. So if you want to do sequence classification or question answering, then there are some task specific variants of this BERT. And other than this, you have some domain specific variants. So one is SciBird, BioBird, FinBird, Clinical Bird, and so on. So how we why we are doing this and why we need these kind of different domain specific? Because when we see the bird, you might have noticed in the previous those slides where Professor Richie presented that these models are basically trained on Wikipedia data or books. So this is a general domain, and if you bring something from the scientific domain or finance domain, these models might not work perfectly on those domains as well, right? Because they need to understand the language. So they have general understanding of the language, but they don't understand the domain specific terms. That's why we need to fine tune all these models, whether it's BERT, Robota, or XLM Robota. We need to fine tune them and then work on those specific examples. But fine tuning is not a bigger task. Bigger task is pre-training these models, which they are already done. So we need to take the models which are already trained from the transformer library, and then just fine tune them, which will take less resources, and then use them for the downstream task. If you want to use text classification, just you use the classification part and do the text classification, right? So now we'll move to next slide. So it's easy if you want to import or if you want to work with BERT. These two things are very important. As I have told you that we are going to talk about only about the sequence classification or text classification. So these two things are important. From transformer import BERT tokenizer, and from transformer import BERT for sequence classification. So you have to take care of these cases. If B is written capital, you have to write capital. Similarly for sequence classification. So all these letters which are for the new word, they start with the capital one. So it's a kind of convention in programming languages, and I believe everybody will be aware of these things. So whenever there is a new word, it will start with the capital, right? So it's different for classes or variables, but yes, it's that nothing. So I hope this is clear. Everybody has installed transformer in their systems, or are you able to import these two statements? You can try running them if that's good. So this is the basic. Yeah, just try to. If you have not installed it, you need to install it. It will be just a Google search, maybe just pip install transformer, and it should be installed there. And all right, you can take some time. You can install it. Yesterday, I think Dewey presented the installation part, and there, uh, she might have told you. I'm not sure whether she told you about. You can do it in Python collab as well, right? You can do it in collab. So whatever we told you yesterday, she might have told you that we need to create Python environments. So whenever we are working with Python, that's a very Python environment or virtual environment is a thing that we generally install because there are different versions of Python or other softwares coming. So there might be issues with each other, or there could be conflict with different versions. So we generally create a virtual environment. We install all those software there. If you need to run your program on some other versions, you create another virtual environment. So I will not go into detail of how to create virtual environment, and that doesn't matter much as of now. But you should be knowing that we should be creating generally virtual environments whenever we are running something. All right. So you just install transformers and then import these two statements. And I hope once you are done with this, we'll move ahead. Till then, some of you can answer this question. It's an easy one. Which of these is a famous LLM developed by OpenAI? So everybody is using something that has been used by developed by OpenAI, and this is also a very easy question. Very good. So everybody is answering it correctly. So it's a GPT-3, right? And then now there are multiple versions of that, and ChatGPT is based on this. So GPT model. So as Professor Rishi told you that GPT is a decoder based model, right? So all are coming from the transformer thing. So this BERT is coming from all the encoders, and this GPT is coming from all the decoders. Whenever I'm on these questions, it creates issues in changing these slides. It just keeps on moving. Maybe I need to exit it and then I need to get out of this. Or maybe I will stop this here and then start again. I will share my whole screen because it's coming in two screens, and that's why it's creating problem, I think. Okay, all right. I will present it again. I hope you can see my screen now. Everybody can see my screen. Okay, all right. So now after BERT, we have Roberta. So Roberta stands for Robustly Optimized BERT Pre-training Approach, and it's introduced by Facebook AI to improve BERT's limitations. So there are some limitations on the BERT. Okay, so somebody thinks their system doesn't allow to install transformer. It says could not find a version that satisfies the requirement transformer for version none. Error, no matching distribution found on the transformer. Try to install in Google Club also, but it's the same thing. Okay, so okay, just you need to see whether you are not making any spelling mistake, or these things are case sensitive, so you have to be careful about that. And you just make a Google search how to install transformer, or maybe I can put something on the chat. Yes, right, it's pip install transformer. So most of the commands are like that, pip install and then whatever is the name, but you have not you have to be careful about these spellings. If you make any mistake in this, instead of Jupyter Notebook, can we use Colab? Yeah, you can use Colab. No problem in that. So it is just a hand-on. If it's just a hands-on, right? So you can do wherever you want. So even if you want to just create a script and you have experience with that, just run that script and it also works. But Google Colab is fine if it is working with that, right? So now we are discussing discussing Roberta. So this Roberta thing is trained on 10 times more data than the BERT, and it's trained on 160 GB. It means the BERT is trained on 16 GB. So if it is trained on more data, it means it should have more contextual information and more understanding of the language. On the right side, you see a table where there's a comparison between BERT and Roberta. So we are training, we have a training data which is less in BERT and 10 times more in Roberta. And then training procedure, it's a standard training methodology. As Professor Riji had discussed, we have two kind of tasks there. One is MLM and another one is next sentence prediction. But this Roberta removes this next sentence prediction and focus on MLM part. Right? Do you have any problem with the audio? Are you not able to listen it properly? Audible? Okay, good. That's fine. Okay. Then there is a sequence length or batch sizes. The bird is using smaller batch sizes and the robot is using larger batch sizes, right? Again, the dynamic masking thing and the computational resources. Of course, this is using both are using considerable resources, but of course, BERT is using less than that. Uh, because in BERT, we have less data. In Robota, we have more data, and we are training on whole data, right? So, okay. Again, as we have seen in BERT, we have Hugging Face Transformer Library, which provide the different models. One for BERT we have already seen. Similarly, we have Robota. So when we get into, so I'm right now I'm discussing this theory part, but it's quite relevant to what we are going to do practically. So if you have imported BERT, if you have installed transformer, so you have done most of your work. Now instead of BERT, you just need to change it to a Roberta. I'm not sure these can work on the CPU, or maybe it can take time, but you can try that because they have, yes, they have more parameters, right? So Hugging Face Transformer Library, it provides pre-trained Roberta model as well. Again, the same thing as we have seen in BERT, it has base and large. right? Roberta base and Roberta large, but you can use Roberta base. And if you talk about case sensitive, the Roberta models are inherently case preserving and case sensitive. And again, we have a distilled Roberta as we have seen in BERT. Even in this case, we have distilled Roberta, which you can use if you have resource constraint. So right now, if you think you have constraint of resources, you can use this distilled Roberta. Just one thing we need to change, and we'll be done with that, right? And this XLM Roberta, as I say, I will be discussing XLM Roberta as well. So this is a multilingual model that has been trained on more than 100 languages, right? And again, we have some task-specific variants and domain-specific variants as we have in BERT as well, right? Now, if you look at this import statement, it is similar to that one we have seen previously in case of BERT. You can try importing these statements and see if they are working on your system or not. So if you have installed transformer, you should be able to run those. So instead of C, we have BERT. If you have used BERT, we have used BERT tokenizer and BERT for sequence classification. Instead of that, just change it to Roberta, and you are done. So I hope you are able to execute this particular statement, and then we are ready for the next one. Can you tell me the major difference between Roberta and BERT? You have four options here. Roberta uses static masking during training. Roberta removes the next sentence prediction. Roberta has fewer parameters than BERT, and Roberta was designed for non-English languages. So what do you think is true? So most of you have answered B, which is a correct answer. So it removes next sentence prediction and only focuses on MLM part, right? So easy question. Now XLM Roberta. Again, the same thing is being provided by the Hugging Face Transformer library. You can use either base model or the large one. Instead of what we have used before, you just need to write XLM Roberta base and XLM Roberta large, whatever you want. And then it has multilingual capabilities as we have discussed, which has been trained on multiple languages. So you can use this model to do cross-lingual analysis as well. So you don't need to train it on multiple languages. It's already trained on those. You just need to see the list of languages which it is trained on, and then do the diverse language task. Right? So we have task specific variants, again the classification, question answering, and other things, and we have domain specific fine tuning as well. So while not inherently domain specific, XLM Roberta can be fine tuned for specialized tasks like cross-lingual sentiment analysis or multilingual document classification or cross-lingual information retrieval. So if there is any cross-lingual task, you can use XLM Roberta for that. Again, for the import, as we have done in BERT, instead of BERT, just replaces by XLM Roberta. So you have already written import statement for the Roberta. So just put XLM in front of that, and you will get these import statements. So I hope these statements work for everyone. You can try this, maybe take a minute, and then move to next slide. Again, we have a question here. Okay, you want me to type those, just a second. You want me to type what? Like these import statements? Okay, all right. So I will provide you the BERT one maybe, and you just need to replace those things, right? So let me give you those import statements. So I have posted this BERT thing. You just need to replace this BERT with Roberta or XLM Roberta, whatever you are using. So what is the primary advantage of XLM Roberta over Roberta? XLM Roberta is optimized for multiple languages, right, or multilingual tasks. So XLM Roberta does not use. So the first is false because it, yeah, It doesn't use next sentence prediction, right? So everybody answered correctly. So we are good to move to next slide now. Let me check if there's a, yeah, you have already answered this one. So second is which task is a typical use case of LLMs? Is it image classification, object detection, time series forecasting, or NLP task like text generation, translation, and summarization? Very good. Again, the easy question. So everybody answered correctly. Now we have a workflow that we need to follow, and this workflow begins with data preparation. I hope you all are aware that most of the time, all the okay. So one of the question I got, I am working on a task related to review or rating prediction using deep learning and have tried implementation model like BERT robot and XLM robot. However, I'm encountering resource limitation as both my GPU and color crash during executions. Could you please suggest some probable solution or alternative approaches to handle such issues effectively? So one of the thing you can do uh, if you're using batch size of 32 or 64, you can try to reduce that. So maybe first try to make it 16, then maybe make it 8. If it doesn't work, then make it 4. So you can make batch sizes lesser, and I hope your code works. So if it's a bigger batch sizes, generally code crashes, and these collab and all they doesn't provide you a lot of resources. So it could be problematic to run these kind of codes sometime with bigger batch sizes. So you can just try that. Even the codes that I have provided you as a Jupyter notebook. So, but I have executed in batch size 32. But if I see the Robota and XLM Robota, they have been run on the smaller batch sizes because they were crashing the system. And if GPU is not available, like if you have even if you have 8 GB of GPU, I think your 32 batch size of Robota is not going to work, or XLM Robota is not going to work. So you need to reduce that batch size first, and I hope it will run. All right. Okay. So now we'll start with the workflow of LLMs for text classification. So the first thing is data set preparation. So this is the thing which is going to take most of the time, or which is going to consume most of the time in your workflow. So we need to collect the data, pre-process the data. If you are using it for classification, you need to label the data as well. So there are, I hope you all are aware that we have supervised and unsupervised learning, even semi-supervised. But if we talk about supervised and unsupervised don't need any labeling, but in supervised case, we need labeling. The classification task is generally supervised task. So the thing or the input that you need to pass to the model should be labeled. In our case, what we are going to do, uh, which is basically my research. I'm going to show you that as well. The data set that I have built for that. So we are using it for classification purpose, and in that we need to mark a tweet because I work on a social media data. So either we need to mark it relevant or irrelevant. But your model, when you're fine tuning your model, it should know what each sentence or what each tweet means, what labels it has, right? So if it is relevant to hydrogen energy, because it's a hydrogen energy related data set, so I will mark it 1. If it is not, then I will mark it 0. I will pass those things inside model. Then my model will be fine tuned or trained on those two data sets. So it's very important that you collect the data, pre-process it, the label the data, and how we have to label or annotate the data. That's also important thing. We discussed that as well. And then we need to split the data into training, validation, and test, and do the further pre-processing. All right. So once this thing is done, once this first part is done, this data set preparation part, we move into tokenization. So I will show all the things, all the codes for these. but maybe we'll divide this whole session into three parts. And in first part, we'll go through these things and understand the theoretical basis of implementation. So it's not that theory, but Professor Ricci has taught you. So she has gone into detail of those equations and all, and how these models work. But we'll basically focus on the implementation part and what things are necessary for that, so that you can after this session you can feel comfortable working with these models and implementing the things. Then the second part of this workflow is tokenization, where we need to convert these data points, or we can say data instances, in numerical representation, which model need to understand. So you can't pass your text or images. If you're working with images, you can't pass them like that. You need to convert them into something else which your model can understand. Once you have done that, you can use fine tuning, right? So firstly, you have to prepare the data. You have to convert that into numerical representation that model can understand. And for that, you have a tokenizer, which is associated with a particular LLM. So the tokenizer have different types. We'll discuss that. So one of them is auto tokenizer, which you need not to worry which model you are using. It will just extract the model that you want to work on the basis of the name of the model, and then you can use that. Otherwise, you need to specifically specify that I'm going to use BERT, Robot, or XLM Robot, or any other model, right? And third one is fine tuning. So once you are done with tokenization, you need to load a pre-trained LLM like BERT for sequence classification. So two import statement that I have shown you. The first import statement is necessary for this thing. We have not discussed anything about data set preparation. We before that we were just talking about how to do tokenization. For that we need to get a tokenizer, import a tokenizer, and for this second part we need to do this BERT for sequence classification. So this BERT for sequence classification will import or load a pre-trained LLM, and then we need to modify the classification head to suit the number of classes in your task. So if you are doing binary classification, you need to set that I'm using two classes, or I have just two labels, 0 and 1. If you have more than that, you need to set that, and then you need to fine tune the model on the training data set using a loss function like cross entropy. So in a neural network, we start with the like first input, then it goes through multiple layers, and when we get output, we check this cross entropy loss, and based on that, we change some parameters. Basically, it's task of that neural network, which does it automatically for you, but it changed those weights and biases, and then retrain the model again and again, right? And finally, when the loss is very less, then you can maybe report your accuracies and all. Okay, so one of the participants is saying that in the module provided today, some files are missing. Can you specify which files are missing? So if you have access to the PDF of this presentation, you can see what notebook should be there. Okay. So okay, you're talking about data set. So because of privacy concerns and proprietary data set, we have not provided hydrogen.csv, but I have provided a data set. So instead of it doesn't matter whether it's hydrogen, it's another data set, but you can just use depression.csv, right? That data set you can use. It is the similar data set. The only thing you will not be able to use from this code will be the prediction part at the end. We are not using it for classification right now. Okay, so we are just using it for text classification. The file that I have provided there is a text file, right? And it has two labels, 0 and 1. So in this case, it's not showing relevant and irrelevant, but it's showing whether it's a tweet related to depression or not. All right. So it doesn't matter which data set you're using. So hydrogen data set I have introduced in my slides because that's part of my research, and that is the main data set we have collected. But all other data sets are already available on the internet, so you can get them online, right? So they are kind of open source data sets. So one of them I have already provided you so that you can practice right now in this hands-on. Okay, so after model fine tuning, we need to training. We need to define the hyperparameters, learning rate, batch size, and epochs. We'll discuss them when we see the code. We also need to use an optimizer and a scheduler for the learning rate adjustment. So we'll discuss these things when we see the code, and then train the model with label data. And we need to validate at each epoch to monitor the performance. So each epoch means one iteration, and we need to run our model for multiple iterations. And at each epoch, we need to see how much is the loss for our model. So we need to reduce the loss, train the model again for another epoch, then see it again, and we'll keep doing this. So we generally don't go till infinite time. We make like 1,000 epochs or maybe 100 epochs, or somebody might make it just 10 epochs, right? And there are things like early stopping, where you can stop your model from running for longer period of time if some conditions like your accuracy is within a limit, or if your loss is within a limit. And once this training is done, we evaluate our model on the unseen data. So this is an important thing, that whatever you are testing, that data should not be available to the model before. So during the training, this part or this test data set should not be available to the model. So the data set which is being used here in the training is different from this one. I'm not talking about the domain, but suppose you have 5,000 data instances. So 4,000 you can use for the training, and those 1,000 which are remaining, you can use them for the evaluation or testing, right? And then you can show the matrices like accuracy, precision, recall, and F1 score, right? And once you have tested, you can do prediction and extract probabilities or labels of from the output logic. So we'll see that, right? And finally, it comes for the deployment and performance monitoring. So it's the real world scenario. We are not going to go into these two things. We are not going to deploy our model anywhere right now, and we are not going to do this performance monitoring thing as well. All right. So let's see what data sets we have. So I have not provided all the data set because these 5 data set that you see at the end, they are already available, the present tweets. I have provided this one, AMI data set, automatic misogyny identification, East Asian hate, IMDb movie review data set, and sentiment 140. The hydrogen energy data set, we have built it on our own. So this is the paper that we have published already. And this paper talks about the data exploration of this hydrogen energy dataset that we have. And the next work that we are working on right now is a semi-supervised text classification, which is a little bit different from what we are presenting today. Because in today's presentation, or in today's hands-on, we are doing it in a supervised manner. That's why I have provided you a data set where we have 5,000 data instances, and all of them are labeled. So out of them, we are going to maybe take 4,000 as a training and 1,000 as testing. But in case of semi-supervised, we generally use a very small number of labeled data sets. And that comes from the fact that from the social media, if you see in social media, we have a lot of data, unlabeled data available, right? So we can use less data and then train our model. So that's a different part. We'll not discuss that, but for your information. So in case of hydrogen energy data set, and I think after 10 minutes we will take a break after 10 minutes. But till 10 minutes, I'm discussing the things that we have done with our data set. Similar things you have to do if you are working with a completely new data set. So these things take a lot of time. So data annotation, we have used 3 annotators, and 3 annotators has marked all the tweets. Not all the tweets. We have millions of tweets, but we have just taken 5,000 tweets, and those 5,000 tweets have been marked either relevant and irrelevant. And uh, we have divided those data instances in training and test of 80 in an 80 is to 20 or 80 is to 2 ratio. So 4,000 are training and 1,000 are testing. So total becomes 5,000. And if you see these two, relevant and irrelevant, they are not quite balanced, but it's okay. We have to take care of these things as well. That almost similar number of relevant and irrelevant instances or any class if it is not relevant irrelevant, or if it's any other thing, maybe spam non-spam. So we should be careful that if they are both balanced, it should be helpful to the model. And then we have a testing data set. On the right side, you see a kappa score and the label of agreement. So this label of agreement in our case, uh, there is a Cohen's kappa and there is a Flynn's kappa. So Cohen's kappa works for two raters only. If two people are annotating the data set, it works with those two data, those two raters only. But if you have more than two raters, as in our case, we have three annotators which have annotated the data. So we have used Flynn's kappa score, right? And if it is more than 0.8, so there are some formulas for that. I will not discuss that right now, but if it's more than 0.8, it's almost perfect. So it can't be completely perfect. You can't get exactly one, because all annotators have different mind setup, and they have different understanding of the data. But still, if it's more than 0.8, it means you have a fair understanding of the data and everybody is pointing in the same direction. So that's what you have to do before doing any classification or any other task. The data annotation is important part, right? And these are some of the imports that we need to do. So what is kappa? So one of question is, what is kappa? Is it threshold? So it's not threshold actually. So the kappa score is used to identify if two or more annotators. So when you have a data set, we need to identify if, so see, I give you some data set, I ask you to mark whether it's relevant or irrelevant. So I give you a tweet, I say whether this tweet is relevant or irrelevant. You mark it 1, and somebody else is marking that 0, and third one is marking that 1. So we need to see how many people are agreeing to that. So the kappa score is actually to check what is the what is okay, can you brief data annotation? Okay, so I'm working on that. uh, so whenever you want to pass any data to your model, as we have talked about classification thing, we are going to do classification, right? So in classification we will have some labels along with each data instance, either 0 or 1. So when you have 0 and 1, that model is going to understand that this particular thing is relevant, this particular thing is irrelevant, or this particular thing is something else, spam or non-spam, if you talk about email spamming part. So annotation is when you ask people to annotate your data set or mark or label that either 0 or 1, because we need to pass some labeled data inside your model. If your model doesn't understand those tweets or those sentence or those data instances, it can't work, right? It first need to understand it need that understanding that this thing is called 0 or this thing is called 1, or relevant or irrelevant. If you have around 10 labels, then you need to see the tweet, or you need to see the data instance and mark them either 0, 1, 2, 3, and so on. Okay, it's written. So this particular hands-on will work go for 3 hours approx. So I think we are done almost 1 hour. 2 hours are remaining, right? So these are import statement that I will show you when I show the code as well. And this was the data processing chart that we have used. We have collected a huge data set for different languages. So where we have used Hindi, English, Korean, and Japanese. We got around 30 million tweets, multilingual tweets. We do some processing. I will not go into detail of all these processing as of now. And then we prepare the data. And finally, we got some data analysis. For this, whatever is given on this slide, you can see the paper I have shown you before. Or maybe I can, if maybe I can provide that link in the PPT as well, or some other resources. All right. So after this, we'll go into detail of hands-on how to do classification all. We'll see the notebooks and we'll execute some of the code. Yes, we'll share the PPT for sure. All right. So see you in 10 minutes. Till then, if you have not installed transformer, and if you're not able to see any of these things working, you can do that. Maybe let me go back to that import slide. You can see this slide and check if everything that you see here, or maybe what I can do, I can stop sharing this one and I will share the code that I have. And then you need to, because this will be the first statement that will be running, this import statement. So I'm again sharing this screen. Can you see my screen where these import statements are given, starting from import OS, import torch, and so on. All right, that's good. So let's come back after 10 minutes. All right, I think we can start now. So is everyone here? Can we begin? All right. So now first thing that we are going to begin with is loading CSV file. That's the first thing that you are going to do. So you have a depression.csv. You can go to that folder. Hopefully that's with you. I have given you a depression.csv like this. When you open it, I'm not sure. Okay, I think you might not be able to see it. Oh, wait a second. And it's on my another screen. So that's how it looks on depression.csv. And these are some IDs. Then it's a text, and then these are the labels 0101. Right. So in this case, it's not about relevance or irrelevance. In case of depression, it's whether this particular tweet is relates to depression, and if it is zero, it doesn't relate to depression. So it means we need to prepare our model in a way that it understand these things, that this particular sentence or this particular tweet belongs to depression and this doesn't. And when this model is trained, we can give some data which is unseen data, and then model will be able to predict zero and ones on those. So the model that you have, the pre-trained model, whether it's BERT robot or XLM robot, that's trained on a general domain. But we need to fine tune our model on this kind of data, right? So for that kind of data, we have we need to load the CSV file. You can have a look at this. So the depression.csv is already clean for you. You don't need to work anything. But if you are working on a custom data set, you need to first prepare the data set. You need to remove all the noise and all. But right now, just assume that you have a clean data set. And that clean data set, you need to use some of the fields which you need to read. And on this slide, you see we have fields equal to tweet text and relevant, and df equal to, I think there's a data set is already there. If hopefully hopefully that's on canvas. I'm not sure whether that has been provided yet, but I think it's on canvas. You can download data set from there. So you can talk to organizer of the course and they will respond you. So yes, it's in data folder, right? So it's in data folder. I have provided two folders. One is data and another is code. So if you look at these two folders like this, have a look here. One is data folder, which looks like this. It has a depression.csv.
You, Deepak, the data is already given to them on Canvas.
Okay, all right, that's good.
Accept the invitation and scan through the information, material, announcement, everything is there.
All right, that's really good. So all these codes are there. If you see these PYNB files are there, and then .py and some scripts are there. So right now this is for my system, but I have provided what is needed for you. All right, so I will go into this. So firstly, you have to load a CSV file. For that, you can use fields, tweet text, and relevant. You can write exactly these statements. Code is already there. Then you can read CSV. Whatever is the name of file, I'm using file.csv, but you can use depression.csv. You can change the name of file and then you can use that. And it says use calls equal to fields. It means you need to use only these two columns, tweet text and relevant. I have shown you the file which have uh, three columns, ID, tweet text and relevant. And some of the files could be larger than this, maybe more than three or four or maybe 100 columns, but we don't need that. We just need only these two columns as of now, right? Yeah, I will open that. Don't worry. So even if I open Jupyter Notebook, you will not be able to copy from that. But yes, you need to take these, right? Then there's a tokenization process. Once that file is loaded, we need to load the data set, loading a tokenizer. which we have already done, and then need to create a pre-processing function that tokenize text, truncate sequence, and all these things. Right, we are going to do that. Now we'll move into the Jupyter notebook. But first, just answer this question. In LLM like GPT-3, what is the purpose of tokenizer? To generate the output text, to convert the text into a sequence of numbers that model can process, right? Everybody gave the correct answer. Okay, so the second one is the correct answer. Right. Now we are going to see these two tokenizers. One is auto tokenizer, and another one is a specific tokenizer that these models have. Right. One is BERT tokenizer. Similarly, you can have Roberta and XLM Roberta. We'll take 2 minutes to discuss this quickly. So auto tokenizer is designed to work with any tokenizer. Right. It could be any tokenizer that you want to use. So you just need to pass the model name or the model name inside auto tokenizer, and it will help that. So it automatically detects the correct tokenizer based on the model name. And ideally, when you're working with multiple models like BERT, Roberta, GPT, or anything else, you can just use auto tokenizer, and it will be very quick. But if you want to do specific, you want to use a specific tokenizer, you have to use BERT tokenizer, then use BERT tokenizer, right? And it will provide all the functionalities to the BERT. All right. So we'll open the notebook of tokenizer. I will go and show you that one. This is the tokenizer.ipynb, or maybe before that, if you want to read the CSV file, I will show you this one. Just give me a second. I will open bird.ipynb, and then along with that, we'll discuss the tokenizer part. But first, we need to see how to read file and all. So I have not executed these codes on Google Colab, but now I have brought them into Google Colab, right? So these are some import statements that are necessary for running your program. And once you do that, these are some of the codes that I have made uh, just to make because I can put my let me show you the folder, because it's organized in a way that it has a code folder and it has a data folder. So I want to put all the codes in this folder you see here, and I want to put all the data on this folder. And whatever code I write in this code folder, I can access this data. So I have written that code in this way, right? So you see, we need to go back a little bit from this current directory where the code is, and then we need to get into the data directory. So that become our base directory, and then we have multiple data files, hydrogen, AMI, HTSN dataset, and all. So right now I have not shared hydrogen, but I can share others as well. Hydrogen, because it's a proprietary, or you can say privacy reasons. So I'm not sharing this one, but yes, or maybe we can see if we can share that. As per the some constraint, we can only share the maybe tweet IDs for these. But this one is shared. You can work with this. There should not be any problem. And then there is a read function here. If you look at this part. So what we want to do, we first pass the path of the file that we want to read, which field we want to read, and then the number of rows that we want to read. In this current file, okay, so I have not, so one of the comment I see on Google Colab, no need for base directory dot depression. Yes, that should not be needed, but I have not run these, or I have not executed these codes on Google Colab. I have executed these codes on my system, and that's why I have written this way, right? Google Colab does not. So I have some so I do have those resources that I can execute on my system. You see a folder, but I have just uploaded it to show you, right? So when we read the data, you need to write this kind of function. So maybe you can try first doing this. It's a easy line. we have a pandas library here, which have read CSV function. You can use this pandas library to read other kind of formats as well. If you have a TSV file or if you have a JSON file, you can read those as well. Even when you get data, raw data from the maybe Twitter or some other, so it says tokenizer config.json not found, the error is coming. Okay, so what statement is giving these errors? In Google Colab, there could be some different imports. Okay, so I hope you can read a CSV file using this function. And then I have multiple files here. You see, I'm just reading only one file, which is hydrogen in my case. You can use depression instead of this. And these are fields that we need to read and then call the read data function, which is written here. So you can take some time and see whether you get something when you execute this one. It's working, that's really good. So just execute this part. If you're working on a system, I think this would work on that. On Google Colab, you can try. I have not tried on Google Colab, but you should be able to read the CSV file, and then all the data from that CSV file should be in this data frame. So from the perspective of PPT, if you look here, we are into just yeah, in this workflow, we are doing this part right now. So we are just loading the data and we will be splitting it into training, validation, and test data set after this. Once this is done, we'll do the tokenization, right? Do you get this one? Is it working for you? Can you read the CSV file? Okay, very good. So this is the easiest step that we can do. Okay, there is an error coming, tokenizer config job, JSON not found. Why this config.json error is coming in some of them? Are you working on Collab or you're working on your own system? Because it's working for others. Let me see why this.
So, just stepping in here, could some of the students for which this system works can confirm? So we know this is some localized errors. Could you guys write in chat if the codes and everything is working at your end?
Yeah, for some of them
Yeah,
it's working.
so we can see that for many of the participants, it's working. So I'm not sure that how much Deepak can spend on fixing
Yes.
some specific problems. I just wanted to make sure that there is nothing. So I think for some where it's not working, it may be that your directory structure is not correct. So check those fundamental and basic things. If you can't get it, it's okay. Just pay attention to what Deepak is showing. So you should be still to understand what's happening, and then you can treat them as a homework. as because you already can see that Deepak is showing on one data set, and we have given you another data set to practice. So you know what's happening. So another thing could be you are not changing the name of the data, as simple as that. So there could be so many uncertainties why it is not working, but because it's working on many systems, so I'm not sure whether Deepak would have time to fix everyone's question. So I'll let Deepak decide how much time he wants to
Right.
assign to that. Otherwise, just think about the rest of the modules, Deepak.
Right.
Thank you.
Yes. One thing you can do if if someone other is using similar system as yours, you can maybe personally ping them, and they can help you on that.
Deepak, uh,
Yes.
let me handle the problem, because
Okay.
they may be some of them are the new to this programming
Okay.
part. They can contact to their academy, and from
Okay.
there, every academy has a TA appointed, and for this
Okay.
purpose only.
All
So
right. All right.
they will
That's
be handling behind. They are handling.
oh.
Yeah.
All right.
So
That will be
Yeah, so
case of
that's
yeah, in case of need, they can write us on the canvas. From there, we are also
okay.
handling.
Yes, that's good.
That's great. Thanks, Namita. So I think for the students or for the participants who are not able to execute in the live sessions, and I'll call these workshop or tutorial as live sessions, it's okay. Don't worry too much, because as Professor Namita said, that you have assistants involved. So you can contact to them and then they will fix it, because we have shared the code, we have shared the PowerPoint. So you have these material to run at your own time. Thank you.
Yeah. Apart from that, we will be sharing the YouTube links as well, so they can go back and look at the problems.
Yeah.
All
So
right.
I would not be really losing hopes if you can't do it in the live sessions, because unfortunately I couldn't get the response about the expertise and the skills on Python. So that's also something, like we have got about mix of about 300 participants. Everyone would have different skills in terms of the technology, in terms of the programming uh, competence, and also in terms of the technical. So I would say everyone should take it at their own pace. If you can follow Deepak, good and well done. But if you are not able to follow, then don't worry, contact your TAs, but listen to this session carefully. So, and write some generic questions, not too much specific that we can't um, address, and also it then takes the time and attention away from the rest of the workshop. So thank you very much for all your cooperation and attention.
All right. So if something is not working, so one of the things that could lead to problem is like if you have hydrogen here, you need to change it to depression, because I have provided you depression.csv. So you need to change it to hydrogen. All right. I will keep looking at the chats as well. All right. So I hope most of you have executed this part and you have a data frame. So if you want to see the data frame, you can just print this data frame, either print df or just write df and control and shift enter, and you should be able to see, or just write df dot head like this. And if you want to just see maybe 5 or 10 of the rows, you can just write this df dot head 5, and you will get those rows, right? So that is just to see the data set. Now next task is to split the data set into training and testing data set. And once this training and testing data set is splitted, we'll use this df train, which we are passing into another function here, to again divide it into training and validation. Right? So df test and df train both are splitted using this function. And when we pass test size equal to 0.2 here, it means we need, suppose we have 100 examples, so we need 80 examples in training dataset, and 20 examples in testing dataset. And there is an argument here, stratify equal to df relevant, and this relevant is one of the column on which we want to see if the data is balanced in balanced for all the classes or not. So out of those, we want to balance the data set. So we'll stratify, and we are using a random state 42. It means we want to make this code reproducible, right? So if you run this code multiple times, and if you have this random state 42, you will always get the same answer, right? So one of the comment is like, this particular portion is not working. I'm not sure why it's not working. Uh, so this files 0 is actually coming from this. So if you have hydrogen here, just change it to depression, because we have a depression variable here. This could be one of the reason, or maybe your directories are not set. You need to do that as well, right? Uh, Moving ahead, once you have done this part, training, testing, and validation split. Once this is done, we use entire dataset for the training. So we are making a list out of it. So we have a train df train. We take tweet text, which is one of the column, convert it into list, and it gives us a list of train text, right? Second, train labels. With the same process, we get the labels as well. So you can do it for validation and labels as well. Why we are doing that? Because that's necessary for us when we pass it into the model. Okay, so one of the question is again, what is random state? So if you want to run your code again and again and see the same output, we use random state. It means if it is 42, another time you have 42, you run the same code. Although we need to set some of the other seeds as well, but if you want to split the data set and you want to see the same number of same kind of examples in training and testing, or training or validation, you use the same random state. So you want to make your code reproducible, right? Does it help? Or maybe I will change my sentence again, rephrase it. So you have a model which takes some input and it gives you output, right? So if you change the input, it is going to change the output. But if you are running a machine learning kind of model or deep learning models, if you change model if you change input every time, you will really not be able to measure your performance. Performance could change depending on the input. So we want to keep our data same in all the run or in all the execution. So we make a random state 42. It means we'll get the same data every time. All right. Now coming to the second one, which is a tokenizer. In this case, we are using BERT tokenizer because we want to work with the BERT model. So these two sentences I have already told you that you have to use these, and we have imported it before doing anything, so that you are already into this line and you already know that we have to do this, and we can run these statements. So what we are doing, we are taking a tokenizer and then loading this model, BERT based uncaged. You can use another model as well. I have shown you multiple models, but right now if you want to use this one, just write BERT based uncaged. Don't make any mistake in spellings, because these things are case sensitive. Yes, you can give any value for the random state. Yes, you can use 1, 2, 3, whatever you want, but keep the same value for always. And then we are providing number of labels equal to 2. It means we have a binary classification. So BERT tokenizer will help us to prepare our model and convert it into tokens, a numeric representation. And BERT for sequence classification will help us to classify the data into these two binary classes, right? So one is tokenizer, another is model. So we have loaded both of them. So you had already executed these two statements. So I hope it should not be a problem. The another thing is optimizer. So we need our optimizer, and we use Adam optimizer here. And inside that we are passing a learning rate. So it tells us what should be the learning rate or the way model is going to learn. whether it should be quick to learn, whether it will be slow. So we can't make it too quick or too bigger or too smaller, right? Sometimes it depends on the data set, sometimes it depends on the model that you are using. So you might need to test with different learning rate. Right now I'm using 5E5. So you can use same learning rate as I'm using for this data set, right? So this will help you to optimize your model and reach to a decision where the loss is minimum. So this thing will help you in that, right? So you use Adam optimizer for that. So once you have a tokenizer, we are creating a function here, tokenize data, where we pass all the text. We pass the tokenizer, which will help us to tokenize all the text, and then the maximum length that is needed for this model. All right. Why we are creating a function? Because we can pass our training data, we can pass our validation data into the same function. Otherwise, you need to write the same code again and again. That's why we are creating a function. And once we use this function, which is this, have been passed to this function, and which we have created here with this statement. So right now we have access to bird tokenizer, and that we have passed to this tokenized data. Inside this tokenizer, we need to pass the text. We need to say whether this there should be a truncation or not. So if it exceeds more than 512, it will truncate it. Whether there should be padding. So in some cases, the sentences or the examples that are you passing, they could have length more than 512, and there could be a length less than 512 as well. So you need to do truncation or padding depending on what you want. And we say that maximum length should be equal to maximum length. And what it is going to return? It is going to return tensors, which are PyTorch tensor. So if you are not working with PyTorch, or if you are working with some other maybe TensorFlow, you need to change it. But right now we are working with PyTorch, so we'll keep it PT, which is a return tensor. And finally, whatever encodings we get from here, they will be returned from this function, right? So you can keep executing this. So for plain text, which we have created here, if you look at this one, we pass it to the tokenized data, plain text and tokenizer. This is the train text and tokenizer in case of this function. And maximum length is the default argument, so we don't need to pass this here. If you don't pass this third argument, it will be by default 512. So training, validation, and test encoding we are creating through this. So if you look at this, we are passing df text, tweet text.toList, so which is exactly similar to this, right? So you can create a third one maybe here, like this, and instead of these two, you can make it this test, and instead of df val, you can do df test, right? So now these three things are exactly same. One is copy of another, and then instead of this thing, this complete thing, we can just write test text. So whatever you want, it's your choice, but I have kept it like this. There is no special reason for this. You can use any one of them, right? Either you evaluate it before and then put it here, or you just evaluate it right now. Okay, but if you want to use it multiple times, it's better that you evaluate it before and then use it. Is this working fine? All right, good, good. So this is the tokenization part. Now there's another function which is creating data loaders. So these data loaders are necessary for the model, and you can create different batches, and like you are not passing one example at one time, right? You need to pass a batch of examples. That's why we need a data loader through which we can iterate and pass it to the model. So what we're doing here, we are passing some encodings to this. What encodings we are passing here? The encodings that we have generated here. So tokenizer has provided you some encodings. So maybe I may need to see my presentation. You can see it here. I will bring those presentation for you where we have tokenizer. Maybe this one. No, not this one. Okay, no, that was another. This tokenizer.ipnb. So this process, if you want to understand in detail, you can go through this tokenizer.ipynb and see what exactly it does. So here we are just working with auto tokenizer. Have a look at this. Instead of BERT tokenizer, just use auto tokenizer from pre-trained and then use this one, BERT based uncaged. Then you pass it to the tokenizer. You will get an encoded input, right? So right now, if you see this one, we don't show what are the outputs. But if you look at this tokenizer dot ipynb, you can see the output of this like this, right? So we have encoded input in the form of input IDs. So these input IDs are actually telling are the tokens of the sentence you have passed or this thing. So each word will be converted into each word will converted into a or each token will be converted into a numeric thing, right? This numeric representation is there. Then you have token type IDs and you have attention mask. So attention mask, token type IDs, and input IDs. These are three outputs, right? And these are going to be necessary for the further input. You have a decode function as well. When you pass input ID to this from the encoded input, it will show you the original sentence. Okay, which is this one. And we have a CLS and separate token as well, which is included by the tokenizer in this case. Okay, you see tokenizer added two special tokens, CLS and SEP, which are classifier and separator to this sentence. So not all models need them, but if something is needed, tokenizer is going to add them for you, right? You can use multiple sentences. Good one. Code is running for everyone. So if you want to batch multiple sentence, here you have seen that we are just passing one sentence, but if you want to batch multiple sentences, that's how you will work with large data sets, right? So again, this is for just one example that you have three sentences, you pass them as a batch sentence, and you will get encoded input for all of them. So you see input IDs. So this is for first sentence, this is for second one till here, and then for third start from here. Once it is done, then we have token type IDs, and then we have attention mask, right? So attention mask is just going to tell you whether it's important or whether attention should be given to this particular token or not. The padding thing that I have shown you, so padding is sentences are not always the same length, which can be an issue because of the tensor. So model input need to have uniform shape. So padding is a strategy for ensuring tensors are rectangular by adding a special padding token to the source of sentence. So if something is smaller, you need to add you need to add a padding, right? Or either on the left and right, depending on where the model is expecting that, right? So the sequence will length will match with everyone. So now you have this batch sentences and you have the output as this. Or before this, you have seen this. It has a smaller length. This one has a bigger length, and the third one has a smaller length. But once you do padding equal to true, the length of all of them becomes equal, and it pads it on the right side by default. It makes them 0. So now the length of all sentences are equal. All right. Now it says the same thing that I have shown above. There is a parameter of truncation. Okay, set the truncation parameter to true to truncate a sequence of maximum length that is accepted by the model. So if something you need to truncate, you need to pass this truncation equal to true, right? And once this is done, this encoded input is going to be a tensor. So how we are going to build tensor? We have already discussed that return tensor should be PT. It means PyTorch tensor, right? You need to use TF for TensorFlow, but right now we are just going to work with PyTorch, so make it PT. And once PyTorch tensors are ready, this encoded input will look like this. So input IDs, and these are tensors now. This is for one, second, and this is for the third sentence, right? Token type IDs, again 1, 2, 3 here. Attention mask 1, 2, 3. So these are for 3 sentences. Once you have more sentences as we have in our data set, we'll make batches of bigger size, maybe 32. So one of the questions that came before was like, why XLM Robota or Robota is not working? Because if you have a bigger batch sizes, you will have multiple sentences here, right? So just keep it smaller. The size will be small, so your model will be able to handle that. So this was about tokenizer. So maybe you can take 5 minutes and run all of them. If something is not working, let's see if, so let's try to run this first so that you have an understanding how this tokenizer works, and then we'll go into a BERT IPY again. The code is running for everyone. All right. Okay, if it's running for everyone, so let's go back to bird.ipynb again. So what we have done as of now, we have imported some of these things, libraries and all, which are needed. You have already used some of them till here, where we are getting tokenizer and where we are creating data loader. But some of the other things like accuracy score, precision score, they will be needed when we evaluate the model. We have already used this OS, we have used Torch, Pandas, NP, and so on, right? Even data loader and tensor dataset we are going to use. And tokenizer and sequence classification we have used. We have used ADMW. So most of them have been used, but these two last statement that we need to use now. So if this much code is running for everyone, we can move into next part, which is creating data loader. So why I have shown you this previous tokenizer.ipynb, because now here you see when we are creating a tensor data set, which we have imported above. So we need here encodings input IDs. So if you are not aware that we should have input IDs like this in the output of encoded input. You will not be able to understand why we are passing this encoding and input IDs here. Similarly, why we are passing attention mask. So if you want to understand this, you need to understand how output of its tokenizer looks like, right? So once you have got them as output, just pass these two things, input IDs and attention mask, to this tensor data set. So whether your data is labeled or unlabeled, it should work for both of them. Why I'm saying it should work for both of them and why it is needed. So when you are passing your training data set, in training data set, you want to keep your labels as well, right? But in testing data set, you don't want to keep the labels in this part, right? Or not for this one. If we are not providing any labels, in that case, it's not needed. So right now, don't worry about this. We'll see what happens when we pass these three sentences here, right? Or when we execute these three statements here. So if labels are provided, just use dataset equal to tensor dataset, input IDs, attention mask, and the labels. If labels are not provided, just remove this last part. And finally, when tensor dataset is created, pass that dataset inside the data loader, create a batch size. So this batch size, which I have given maybe somewhere up, or I'm not sure. Let me check it again where I have provided the batch size. Oh, I have provided it here, right? So batch size, which is coming as an argument in this function, it's a 32 right now, but you can reduce it if your model doesn't work. You can make it 16, 8, or 4, and you make it shuffle equal to true. So when we call this particular function, it is going to return a data loader, right? Now for this bird, I have created a batch size of 32. I want to create a train loader, which I want to pass to a model after this. So I will call create data loader function, train encodings, which we have created here from the tokenizer, pass the batch size, which is this 32, and these two are default variables. So by default, it takes batch size of 32 and labels none. So if unlabeled data is there, you just pass encoding and you are done. But right now, as we have some labels as well, so this is the third argument. So we need to pass batch size of 32 from here, or maybe if you want to change it, just change it here, 16. Or if it's not working, 8. But for bird, in my system, it was working on 32, so I am running that. Feel free to change this value. And then train label, which we have got here, you remember it, we have calculated it above, right? So we are passing these three things. Similarly, again, these two statements are copy of the first statement. In the create data loader, we are passing validation encodings, batch size, which we have passed above as well, and validation labels. For the test loader, test encodings, batch size, and again, the test labels, right? So you can try running this statement as well. Once it is done, you can see, you can just print train loader or validation loader or test loader to just see how it looks. Okay. And once this is done, this is the statement which you all should run. If something, some GPU is needed for running the codes, or if GPU is present in your system or not, if you want to see that, just run this particular statement, device equal to torch.device CUDA 0. If torch.CUDA is available, else CPU. So in my case, if I print device, it shows CUDA. It means CUDA is present in this device on which I executed this particular code, right? So just see if CUDA is available or not, because there might be things for which you need CUDA, and if you have just CPU, it might take a long time. Okay, so it's good to check that. And finally, when you have CUDA, If not, CUDA GPU can be used. All right. So have you executed the code till here? So if you have done this far, you need to good. So you need to pass your model to the device. So now you are going to run or execute your model on this device, whatever is the device. If you have CUDA, run it on CUDA. If you have CPU, run it on CPU. It might take time if you have CPU, but it's okay. All right. So now if you print your model, it looks like something like this. But for sequence classification, we have embeddings and all. Everything is given here. So we'll not go into detail of this. So dropout layers and all are there. Now I'm setting a learning rate, which is 5E5. Okay, so I'm doing some weight decay as well. Scheduler I'm not using as of now. You can just, if you want to use it, you can use it. But right now I'm just commenting it, right? And even if you want to comment this statement, so we want to put a parameter, or we want to decay the weights by uh, some parameter, but just use this one. Simple learning rate, nothing else. So we till now we have set all our hyperparameters and we are ready for the training. And now this is the training function. Okay. So once we discuss this thing, then we'll take maybe a 5 minutes break again. All right. So far everything is running for everyone or most of you. All right. If it is running for most of you, then it's good. Okay. So when we want to train the model, so this particular function is written for running one epoch only. We will pass the model which we have created here. We have already got a model in. Let me show you that thing. Yeah, we have a tokenizer, we have a model, right? We have a model here. So we are passing that model here. We are passing our train loader that we have created. We are passing our optimizer and we are passing our device, right? On which we are going to run this. So for training, we need to set our model into training mode. So it is very necessary and you have to keep this thing in mind. Sometime you might not put your model into training. So no parameters or no weights will change, right? If you compare this training with validation or evaluate function, we are using model.eval. It means if you evaluate your model, your weights are not going to update. That's why you're putting it model.eval. Just evaluate, don't update any models, right? In this case, you need to train the model. So that's the basic difference. You have to be careful about these things. Then we are setting some variables so that predictions are stored in this predictions and labels are which are actual labels are stored in this particular variable. We are going to create loss. We are going to store loss or add loss one after another epoch. And this train loader iterator or TQDM that you see here, it is just a progress bar. So once that one of the statement on the chat, I see training 0%, taking too much time. Yeah, it can take too much time if you are running on maybe CPU. If it is on GPU, I think it should run. But this TQDM is going to show you progress like this. Okay. Then a train loader, because you have created different batches or you have provided a batch size. So if you have provided, suppose you have 100 examples and you have created a batch size of 32, so it will create 4 batches and each batch will be executed in this function or in this loop. So for batch in train loader, it means for 100 examples, if you have a batch size of 32, it will have 4 iteration of this loop. And what we do, optimizer dot zero grad, it means we need to reset the gradients after each epoch, after each iteration, right? So that they are not accumulated. And every batch will have input IDs and attention mask as you have provided before, you know that, right? And then we have labels as well. So each batch will have these 3 things. And from where we are getting these 3 things, we have already created them here. See, input IDs, attention mask, and the labels. All right. And then we pass these input IDs to the device as uh, we have kept our model into the device. So we'll keep all these things into the device, whether it's CUDA or CPU, but we'll keep all of them in the same device. All right. Once it is done, we need to pass these 3 things into the output, pass these 3 things, input IDs, attention mask, and labels, and we'll get the output, right? So after this one, we'll take the break of 5 minutes. Let me finish this. So once you pass all these 3 things to the model, it will give you the output. And on that output, you calculate loss. And then when you have these 2 statements, loss dot backward and optimizer dot step. So in the neural network, you go in the forward direction, you calculate the loss, update the weights, and come back again. So the process goes on like this, right? So all these things that are happening here are, this is the backward pass, and this is the forward pass. All right. And then we keep on whatever loss we have got here, we add it to the total loss. All right. And then we are calculating our predictions. So we have some output logics. I will not show these details, but output logics are kind of raw numbers. And when you do argmax on this, you get the highest one. And finally, when you get that highest one, that becomes a prediction for you, right? So that prediction will be appended to the all prediction, and all labels will have the actual labels. And again, this thing is a progress bar or just to show you the output. So when this loop is done, you call a function called calculate matrices, and in this calculate matrices, you pass labels and predictions. It means you need these 2 things. You have the actual label and you have the prediction, right? And for that, we calculate the matrices. What are those matrices? Those are given here, the labels and prediction. And on the basis of this, now the second last statement in the import will be used here. The accuracy, precision, recall, F1 score. And if you want to keep confusion matrix, you can keep it. Otherwise, you can remove it as well. So confusion matrix will show you something, right? So how many true positive are there, how many correct predictions are there, and so on. And similarly, this evaluate model, it's almost similar to this. Few things are changed, like we have made it model.eval, and all prediction and all labels and everything is same, right? But we are doing it either on validation data or testing data. So if you understand this particular function, the training epoch one, you should be able to understand this evaluate one as well. And the calculate matrices is like just using functions like accuracy score, precision score, recall score, F1 score, and confusion matrix, and pass labels and prediction to them. And while calculating precision, recall, and F1 score, we pass one more argument, average, equal to how we are going to average the score. So if you have a balanced data set, like if you have 100 data points, 50 in one class, 50 in another, then it's fine. But if you don't have that, you need those. You need to see what should be the weights of those predictions, and then calculate the score. And finally, this main training loop is to call all these 3 things: training one epoch, validation or evaluation or calculate matrices. So what we do for epoch in number of epochs. So whatever number of epochs you are going to run, in this case, I have run set epoch equal to 5. So you can run it for 5, 50 or anything else. First, we'll run train epoch once. We'll print all the matrices. We'll call validation. We'll print all of them. And this is running inside a loop. See, training and validation is running inside a loop. And when everything is done, we'll see if test loader is there and we'll call evaluate again. So evaluate is working with two loaders. One is training load, one is validation loader, another is testing loader. And we are again showing our matrices, loss, accuracy, precision, and everything, right? And finally, when we are done, we'll save the model so that we can load the model later and do some predictions. All right. And finally, we call main training loop, pass model, loaders, optimizers, and so on to this particular model. So in some cases, what we do in the validation, we keep track of loss function or accuracy if something, if loss is decreasing or accuracy is increasing, and if it gets stabilized after a few iterations, we do early stopping. So it means if you are running your model for 100 epochs and your model is not making any changes after 10 or 20 iterations, you can just stop your model. We have not done any stopping in this case, but you can do that as well. All right. So when I run my model, it looks like this. And finally, I get test matrices like this. So accuracy is coming around 9.92, but it's for hydrogen data set. You're running it for depression. So maybe it should be similar. I have run it for depression as well, but it comes out to be similar to this, right? And then model is saved. All right. And how do you say, how do you get that saved model? Again, do that same thing, tokenizer and BERT for sequence classification. Right now, we are not passing BERT based uncaged here. If you look at the difference, we are passing BERT model, which we have saved here. It means tokenizer, we are loading from this pre-trained loader tokenizer, but sequence classification, we are getting our train model. So once we get our train model, we have a function here which do some classification. We pass it like this, predict word classification. I will not discuss this word much because we are again using tokenizer and all. And this thing we have already done in the training part. But when we are doing bird classification prediction, we pass one sentence or one tweet and we get some of the probabilities. So it tells us that this part is irrelevant or this tweet is irrelevant. And I'm passing many more like this. So you can see their outputs as well. All right. So we can take a 10-minute break and then in 10-minute break, you can execute or run this sheet if you want, if you are getting any errors. And after that, we'll change a little bit in this and we'll see the Roberta one and the XLM Roberta. And finally, what I will do, I will show you the ensemble. So for the ensemble, we need saved model. That's it. So you can run it later. You don't need to have it everything right now. But if you understand BERT, you can run all of them. All right. So let's come back after 10 minutes. I think it will be 2 p.m. in India that time. So we'll meet at 2. All right, everyone. I think we can start now. After this, we'll have 45 minutes to wrap up everything. So, can we begin? All right, so we'll start. Okay, so as of now, what you have seen, let's recap it from the top. So we have imported some modules. Uh, these things, these two statements that you see here, one is base directory and another one is for getting the data. This is just path setting so that your code works correctly in the way I have shared the directory structure. One is data folder, another is code folder. So that's a good way to organize your codes and data and keep them separate as well. Okay, so this is the read data function for reading your data in a CSV format. Then we have files. You can change it from hydrogen to depression because I have shared a depression file, depression.csv. And then there are fields that you need to read and pass to the read data function. Split the data set into training, test, and validation, and converting them to the list so that we can use it further. Loading the tokenizer and model, then call tokenize data function so that you can tokenize your data. So you can tokenize your train data, test data, and validation data, and then get the encodings. Encodings will have three parts: input IDs, attention mass, and another one is type. All right. So we have another function, create data loader, and this create data loader function will right. So we create data loader out of these train encodings, validation encoding, and test encodings, similar to what we have done in the in creating encodings here. So we are creating data loader for them, right? Putting the model to the device. Then training, we have seen how we train, how we evaluate, calculate matrices, and then finally main training loop, which wraps up all these three functions into into same loop. So we train, we evaluate, and then we save the model, right? uh, we have a main training loop which is calling which is passing some parameters and like training loader, validation loader, and test loader, and there are some other parameters as well, so you can change the epochs from here. And finally we get some output. These are the validation matrices. So we every epoch we are getting training matrices and validation matrices. So as loss should decrease and accuracy and other things should increase, right? That is our motive. If it doesn't happen, there might be something wrong with the model or some parameters we need to change and all. So deep learning and machine learning are all about setting the hyperparameters and retraining the model again and again, right? And we save the model, and finally we load this saved model, use this predict word classification model, and then we pass some sentences. So I hope you have already run this. Because you are running a depression data set, so you need to change these sentences. These are related to hydrogen energy, right? So what you can do, you can keep put some similar sentences of smaller length, maybe 10-20 words, as you have seen in the file of depression tweets, and see whether you are getting correct output for those tweets or not. Okay, so you can create your own custom sentences and try that. All right, that's the one thing. So if you look at this file, bird.ipynb, we have used a BERT model. If you want to use a Roberta model, you need to make small changes. What small changes? Can someone tell in the chat what thing we should change here so that we can use the Roberta model for classification purposes? Only few changes that we have discussed during the presentation. which line we are going to change here? So we are going to change the import. What import? This line, right? Instead of bird tokenizer, you need to get Roberta. Okay, so one of you has used from transformer import something, right? So tokenizer should be Roberta tokenizer, and bird for sequence classification should be changed to Roberta one, right? So there is another code, another IPYNB file, roberta.ipynb. So we change this thing here. Other things are almost or exactly same. The changes will happen when we load the tokenizer and model, which is happening here. Now everything after this is going to be exactly same. Okay, no changes. See, so using a model is a easy task. You just need to load that model, load the tokenizer, and you are done. So all these things that you see are exactly same. You don't need to make any changes. You just need to make change in one thing that was at the top. And once you are done, run your model and you will see. So you don't need to run this model as of now. If you have run bird, that's fine. As a homework, you can do that later. Use separate model and see the accuracy and all. And this is the accuracy that I get using the Roberta. And similarly, the XLM Roberta is the only thing you need to make changes. Instead of importing tokenizer and sequence classification model of bird or Roberta, you need to do it for XLM Roberta. Okay, and everything will remain same. One important thing I want to tell you here, when my screen is shared, I'm not able to make changes, or I'm not able to, okay, I think I got it now. So this is the file that you see here. It's a bird.py. So before, the file that I have shown to you were IPYNB file or Jupyter Notebook file. But the thing is, when you want to run your code, so Jupyter Notebooks are good for presentation and seeing the output later. But if you want to run your code, or maybe you want to run it on server, you need to create a script. So what I have done, this bird.py, you can find this code as well. I have uploaded this one. So everything is same. I have imports. I have those path and configuration. All the functions that you have seen in the IPYNB file, all are here. The only change that is going to happen in this case, because we are going to run a script, is at the end, which is this one. So now I have created a function which set these parameters like batch size, what should be the file path, what should the field. Then from here, I'm going to call those read data function, splitting the data, getting the tokenizer and model, then creating those encodings, creating the loaders, and setting the device, passing model to the device, setting the optimizer, and then calling the main training loop with all these parameters that I have done before. But now I'm doing it through this function, right? Because I will run this file as a script. And once it is done, so this is the main code that we need to write and work with that. Depending on your data set, because I have a hydrogen data set, so what I do, I use a saved model for classification, and I have not made any changes to this. I have kept this thing after that, once this main training loop is evaluated, right, or executed. And then I have parsed all the, so again I have created a function for this which were already there, but at that time these values were not there, or these tweets in this form were not present there. So I was passing each tweet in this function, and then it was giving me probabilities and all. But now I have put all the tweets together in a list, and I'm passing this for tweet in tweets, and now I'm passing each tweet in this function, and it will again provide me some these probabilities or predictions of the model, right? So let me, I'm not able to, because it's on another screen, so sometimes it becomes difficult to get that. So if you see here, so I have run it for bird depression as well. So what you have to change, bird which I have run for hydrogen, if you have to run it for depression, only thing you need to change is uh, just the file name, which is depression, and that you can do from last one, the main function. Just change it here, and you are going to run it for another data set. So if you want to run for another data set, just make a change here, and everything will remain same. Okay. Next, we have. All right, everyone. So can you see this code? Bird.py. And if I run this script in my system, which is which I run on a server, so I get output like this. I already have this. This code bird.py will run like this, and it will give me output. So directly I can go at the end, and it will show you the performance at the end, which is here. So these are the test matrices: accuracy 93.8, precision 93.8, and so on. Right, and model is saved. So I have not provided this saved model because it was too heavy, but if you want to run and see the model, just here, the BERT model is here. So it is, when you save a model, it looks like this: config.json and model saved tensors, and it's a big file. So that's why I have not uploaded. When you run your model, you will get something like this. So if you look at properties of this, it's around 417 MB. Similarly for the robot and all. All right, so you can directly run this script bird.py. Is this okay? Are you able to run this? Does it give you something, some output? Does it show any progress if you run this script bird.py? So okay. So you have a question like, if you have 10 labels, then how we set like one for what? And so it doesn't matter what you set for what. So because you suppose you have 10 statements, you understand that this particular category should be one. Just write one in front of that. You can assign randomly any category. It doesn't matter what you are doing. Maybe we take an example. Maybe uh, let me find an example where you could have 10 categories. Maybe you need to identify the fruits, right? And you have a statement which actually tells us which fruit is this. So if it is apple, you can make it either one, or you can make it two or three. It doesn't matter. But if that similar sentence is coming every time in your data, so it should point to that one only, not one once and twice another time and so on. So if it is one, it should be one for all the apples. If it is two, it should be two for all the apples and so on, right? So it is possible to modify BERT internally. BERT internally means, if you want to modify the BERT internally, so it means you need to retrain that BERT model, right? So training is again a huge task. All right. So generally, when we work with BERT and all these LLMs, we generally do fine tuning. All right. Okay. So one more thing I want to show you. So I have shown you the BERT. I have shown you the. I will close this tokenizer. I will close this BERT file because I want to access one more. XLM robot is also there, but I want to show you this ensemble thing. In ensemble, what we do in ensembling, we generally combine output of multiple models, and then we get the average of all of them. So it means if one model is deciding something or predicting something, another is predicting something else, or maybe they have different probabilities, we'll just average them, or there are some other ways of adding the output of or prediction of different models. So what we are doing in this case, we have BERT, Robota, and XLM Robota. Uh, right now, we'll just take two of them, BERT and Robota. So we read the data again in a similar way as we have done. We create those train text and train labels as you have done in BERT. It's exactly the same. We are not doing anything different. We have a BERT tokenizer. We have a Robota tokenizer. So if you have already run your BERT model or Robota model, then the classification part, and your models are saved, then you will be able to run this ensemble thing right now. Because what I'm doing, uh, I am directly loading BERT for sequence classification, that BERT model that I have saved and the Robota model that I have saved. I'm directly using those saved models. I'm not retraining them again here because they're already trained and I have saved them. So I'm just using them. But if you want to do those fine tuning again, you can do that as well, right? Similarly, I get encoding of BERT, encoding of Robota, so they could be different. So we are taking them. And in ensembling modeling, what we are doing, we are passing encodings of BERT, encodings of Robota, BERT model, Robota model, and validation of text and validation text and labels, right? So the input ID we take from here, the attention mask we take it from here for BERT and Robota, both of them, right? And we are doing it in a loop for this var text. Then we take output of BERT model and Robota model. So these things are exactly similar what we have done before. Now we find out the probabilities. We combine the prediction using the ensemble strategy. There could be multiple, but we are using average one. We are passing output of BERT and output of Robota, and those logics when passed, we we pass it to the softmax function, and then we get the probabilities, right? And when we get these two probabilities, we just do ensemble by taking probabilities of BERT and probabilities of Robota, and it should not be three, it should be two, because we have two probabilities here. If you are using all these three, then we can divide by three, right? So, and finally, when we do prediction, again use the torch.argmax. So argmax is like finding out the prediction with the highest threshold or highest value. So that become your predictions, right? And you keep on appending those prediction to the prediction variable. And in a similar way as you have done before, again calculate those matrices: accuracy, precision, recall, and FL score, and finally print them, right? For this part, I have already executed, which you can see here. So you get an ensemble accuracy of 94.3. So earlier you have seen in the BERT and Robota we were getting around 93, but here we got 94. So basically we use ensemble to enhance the performance of your model, right? So if you have different decision makers, you just combine there with different strategies, of course. We have used average strategy for this, combining these predictions. And finally, we got these outputs. All right. So this was about it. Let me go to the presentation and see what we have now. So we have discussed all these things: Python code, Robota notebooks, XLM Robota, Ensemble notebook we have discussed. Now you already have access to these codes and some of the custom data set. So you already have a data set, you can run that. But if you want more data set, you can also go to Kaggle and get some classification data set. This one is for this code is written for binary, but you can easily change it to 3 classes. All right, that could be your homework. So let's see, there are some questions as well. How to fine tune any LLM models, or how to customize BERT fine tuning. What change in parameter we need to BERT to work on multi-class classifier. Okay, so you have seen when we were uh, loading model for classification, I think here. if you see that loading thing, this one here, we have set a number of labels somewhere. Let me go when we are loading model, or maybe at the end in the main function, somewhere here. See number of labels. So it means this is binary classification. You need to tweak your code a little bit to make it to 3 classes. Okay. So some of the questions are how to fine tune any LLM. So we are fine tuning BERT and XLM robot and all. This is the fine tuning that we are doing. We are using our own data. So these models, these LLMs are already trained, right? They're already trained on the general domain, like Wikipedia data and books. But what we are doing, we are passing our own data set. So the named entity is a different task. Right now we're just talking about classification part. If fields are 3, so what fields you are talking about? Like, so right now we have just text. That's one field. If you have 3 different field of text, so maybe you can try concatenating all of them and then pass it to the model. That could be one way. All right. So we'll go through the presentation again. So we have discussed most of these things. Now you can modify codes and other custom data sets. So it's easy. First, you try by taking other data set, or maybe just one data set. Try different models, then take other data set and use these models that you have developed. It means, are we fine tuning all the model parameter? So the main model is frozen, right? So you are not changing every layer. You are making change in maybe last layer that you are adding, or the classification head. All right. So these things are what we have discussed today. Some models like BERT, Robota, and XLM Robota. Mainly we focused on BERT, and with minor tweak or minor changes, we have moved into Robota and XLM Robota, and then we talked about ensemble modeling as well, right? So these are the ensembling techniques, and this is the thing that we went from a code, like starting from data preprocessing to training and evaluation, and finally the ensemble integration. All right. So resources I would like to share. And okay, the last slide is this. This is me. This is our research group. I would like to thank Professor Richie and Professor Namita for organizing this and inviting me for the talk. So this is our research group website, and this is me on the LinkedIn. So one thing I want to so there is a question like resources. Yeah, resources are already shared, and I have shown one slide. It's a Hugging Face NLP course. You can go to that, and I think it will be a very helpful one. All right. So thank you so much, everyone. This is
Thank you so much, Deepak, for running this module and hands-off workshop. It's a quite detailed coding and really goes in depth how these language models and coder-based BERT and its variants can be utilized for classification purpose and for other purposes. So I'd like to thank all the participants for attending this session, and I understand that there was some confusion in terms of lunch break. So we'll make sure that next Saturday, Sunday, we have sorted out those times and there are no confusion as such. Yeah, so I would highly appreciate each of you to go through the module 1, module 2. Professor Namita is making some quizzes available, so go through them. So that those are the good quizzes to reflect on to what we have covered in these 2 modules. So these 2 modules covered some of the basic. Again, in the next module, we will cover some basics on GAN model. GAN model are used for one of the most common generative model, and some use cases in terms of some of the data sets. And after that, we would start the use cases. So I'll also encourage you to think about how you could use these technologies for your research purpose, for your organization productivity purposes. And we would have some nice discussion in the last module where you can propose, and we can then have some discussion that would that be good option or not. Thank you very much. And now I hand over it to Professor Namita.
Yeah, thank you, Richi. Thank you, Deepak. So Deepak has taken lots of problems, and in detail, I think participants are very happy to run them quickly in parallel with Deepak. And some of the participants are facing the problem just because they haven't joined the Canvas. I request everyone to please join. Just share the email again with your email ID you have registered with. The same email ID we are using. There may be some difference in the email IDs. That's why you are not able to join. This may be the problem. And as Dr. Richi mentioned, that we have quizzes planned for you, but because the invitations are pending, so I'm waiting everyone to join, then only we'll be able to offer the quiz. Otherwise people may not join and may not get good marks, means 0 marks. So out of 3 quizzes, 2 are compulsory. So please make sure that you are getting the quizzes, materials, announcements. So many things are going on Canvas. Kindly help us joining the Canvas and WebEx as well. We are fixing the problems you are facing, because we have total 5 academies together: NIT Patna, IIIT Jabalpur, IIT Roorkee, MNIT Jaipur, and IIT Guwahati, and 500 plus participants across the academies. So it's a big participation. Thank you very much for joining. Thank you again, Deepak. It's a very nice session. I have also attended, full attended, and lots of takeaways for me as well. Thank you so much. Thank you, Richi. We'll be meeting again on next Saturday.
Yeah.
9 a.m. Indian time. 9 a.m. Indian time next Saturday. That is 18th of January, right?
Yes.
Yeah, 18th
11th
January,
and 18th,
AM.
yeah.
Yes.
18th of January, yeah.
So we'll be here in AI. कुछ लोगों को, if they are facing some problem and they are in Jaipur, they can come to our academy. This is, you can see, this is a big lab here. We have around 120 plus computers, and you are invited to come here. We are here to hear TAs as well. You can do it online. Local systems पे we can offer you to do. Thank you very much.
Thank you, everyone. Have a good night.
Thank you.
Bye-bye.
Bye-bye.